Hi again, Bill Witte here, back with more pre-algebra. Today's wisdom is that a test is looming. Now you don't need to be afraid of this test because you've done your homework and you've done the review test. You're ready to rock and roll, okay? You know what I'm concerned about though? The material that we're learning here, you're going to use in the next class, okay? I see people that have this phenomenon, or they create this phenomenon I like to call motivated forgetting, okay? I remember when I was in high school and college, when I took a history class or a rote type vocabulary class, as soon as I finished the test, I'd go, whew, let me forget that garbage, okay? Well, you can't do that, because as I said, all of this stuff is going to be used in the next class, okay? So you need to put it into long-term memory, forever memory, okay? So please, please take that attitude, okay, as we go through the test, you know, after you take the test. Okay, now if you haven't taken that attitude, you can always, of course, go back and review using my homepage, where you say, where is it? At www.montgomerycollege.edu/pre-algebra. Okay? I guess it's time to see what we're going to, before we cover our new stuff, which is pretty cool, okay, integers. Let's remember what we did last time with integers, okay? We're not ready to multiply and divide until we add and subtract and various other things, okay? Well, we started with the number systems other than the integers, and that was, remember the natural numbers? The natural numbers, if we started counting, the first caveman, if you would, started counting naturally at 1. Okay, and that set 1, 2, 3, and on into infinity is the natural numbers. You knew that. Okay, then the caveman decided that there was a need to represent 0. So we threw that in there. Of course, that was a different set. He had already created the natural numbers, so he called that the natural numbers with 0, the whole numbers. Okay, then the caveman started borrowing things. Well, as you and I do all the time, he went into negative. So he had to represent negatives. That's the integers. That's what we covered last time, basically. The integers are the negative numbers in addition to the whole numbers, if you would. Okay, now note what's not there, if you would. Note what is not there, what we have looming ahead of us is the fractional type things, like 1.5, 1.5, that kind of thing, the numbers in between. So the integers, if you would, are the signed numbers. Only the positive numbers, 1, 2, 3, nothing in between. The negative numbers, and what's in between them? 0. Okay? So the positive numbers, the negative numbers, and 0. Now, it's important to note you're going to have to keep this number line in your head kind of a thing when we test to see what's bigger. Because things that are bigger, what defines whether something's bigger? As simple as it may seem. Something's bigger if the farther to the right we go, the larger the numbers they get. Okay, so if it's to the right of something, it's larger. If it's to the left, it's smaller. Okay, and you're thinking, oh, that's easy. Well, we'll see. When I say that things aren't equal, one's bigger than the other or one's less than the other, we're going to be dealing with some notation, you may remember, called inequality, not equal signs. Okay, and they are as follows: the greater than sign that looks like this, and the less than sign that looks like this. Now, I don't like people thinking of that as the greater than sign and the less than sign, okay? That's something to memorize, and as I said before, I'm no good at that, okay? Rather than thinking of greater than and less than, think of just, in general, their inequality signs. I'll show you why. Because this sentence, for instance, 5 is greater than 3. In the future, you'll need to be able to read that perhaps backwards. Of course, if 5 is greater than 3, that's a greater than sign. What is 3's relationship to 5? 3 is less than 5. So you'll have to perhaps read that backwards. We could read this 2 is less than 6, but also in the future, I'd like you to read it 6 is greater than 2. So that sign really isn't, I'd like you to think, not a less than sign or a greater than sign. It's a, in general, inequality sign that you'll need to know how to manage, okay? Now,
Wait a minute, 99. That gives me an idea.
Rather than memorizing, you may remember we gave you a way to remember how to actually say these things. And that was really two ways, okay? One of the ways is that the arrow of the sign, of the inequality sign, always points to the smaller number. I don't like that one. I don't think that's very creative. The reason people use that is later on when we graph these things, the arrow will point which way to go, which way to shade. That's kind of nice, okay? But I think the easier way to remember is that the inequality sign looks like an alligator, and the mouth always opens to the bigger number. Okay, the mouth opens to the bigger thing, okay?
Wait a minute.
Okay, now, the opposite of a number we covered. What is the opposite of a number? The opposite of a number is a number that is the same distance from 0 on that other side of 0. For instance, the opposite of 3, there's 3, let's go the other way, is negative 3. The opposite of negative 4, let's go the other way, is 4. Simple, huh? The opposite of negative 23, now you're going to have to use your imagination here, you see. You have to get that number line in your head. Go the other way is positive 23. Okay? And at this point, that may seem real easy. Okay? You say, oh, geez, just switch the sign, idiot. Okay? However, you know what people are going to confuse opposite with all the time? Let's take a look. Consider distance. We know distance. If you drove 7 miles to school, you know, the question asks, how far did you drive home? Don't be saying -7. Okay? You still drove 7. Distance can never be negative. Okay? Even if you drive backwards or something, okay, or upside down, distance can never be negative. Now, what we're talking about, confusing opposite with something. Opposite was easy. Okay? What do we confuse opposite with? The absolute value. People screw this up. You know what the absolute value of something is? The absolute value of a number is that number's distance from 0 on the number line. Okay, now remember what I told you. Distance can never be negative. So, and that's read the absolute value of 3. The absolute value of 3 is the distance 3 is from 0 on the number line. The distance from 0 on the number line, well, distance can never be negative, so it's 3. Okay? Now here's the screwy part. The absolute value of 3 is 3. What's the opposite of 3? You remember what we said. It's -3. Okay, that's easy. Okay, people say, oh, now I understand the difference. Okay? Let's take a look at what's the absolute value of -4? Well, it's going to be the distance from 0 of this thing. Now, how far away is -4 from 0? Distance can never be negative, so it's 4. Okay? Now, so the absolute value of -4 is 4. What's the opposite of -4? It's still 4. So you really have to know your definitions. Okay? They're not just, you know, opposites of each other. Let's do one more. The absolute value of -23. That's the distance -23 is. It's way out there from 0. Now, distance can never be negative, so the absolute value is +23. Okay? And in this case, it's the same as the opposite. So you can see how people could get confused with this. Okay? What else did we cover? Adding integers. Okay, we got a whole deal, adding and subtracting integers last time. Well, I really break this into 3 categories. First one, adding integers with the same sign. Well, those integers are on the same team. Okay? 0 was the referee. So we break them into teams. The positive team and the negative team. They get together.
Totally.
Well, ooh la dee da.
Okay, now we broke them into teams. I hope you can appreciate, that's easy to do. When integers on the same team are going to add to each other's strengths, it's like anybody does on a team. For instance, -7 and -2, they're going to add to each other's strength and get -9, you have even more negative. Of course, you knew 7 plus 2, a positive and a positive, make even more positive, okay? This is almost too easy. Negative 3 and negative 5 make even more negative. They add to each other's strengths because they're on the same team. Of course, 3 and 5 add to each other's strengths and get 8. Negative 12 and negative 4, same team, add to each other's strengths, so same sign. Negative 16. Of course, regular 12 and regular 5, I shouldn't say that. I should say positive 12 and positive 4. They add to each other's strengths. Okay, so that's not too bad. The problem occurred when they had different signs. Okay, now we had a battle. What I mean by different signs, I mean one of them was positive and one of them was negative.
Of course you realize this
Means war. So we began our battle. We cleared away casualties. Remember what casualties were? And we displayed the result. Let's do one.
Bring it on.
Negative 5 goes against positive 3. We have a mixture here. We have one of each. Okay, we began the battle. Come on out, negative 5. Okay, positive 3. Okay, now it's time to clear away the casualties. Now remember, when each negative meets a positive, what happens? Casualty. Got another meeting. Casualty. Another meeting. Casualty. Okay, we've cleared away all the casualties and display the result. In this case, the answer is negative 2. So that's going to be a whole different deal. Where do we get negative 2? We have to come up with a rule.
Do that again.
Okay, let's do another one.
I have been chosen. Farewell, my friend.
Yep,
Go
that's
on
right.
to a better place.
Negative 2 is going to verse 6. Now we got a battle here. They're not adding to each other's strengths. There's going to be casualties. Let's begin the battle. Come out, negative 2. Okay, 6, 3, 4, 5, 6. Okay, let's clear away casualties. There's a pair. There's a pair. And that's it. What are we left with? 4 positives, so the answer's positive 4. Okay, now it's nice to be able to visualize it, but if the numbers get really big, you're going to have to come up with a rule. For instance,
yourself for immediate disintegration.
if we have negative 25 going against
You better say a prayer,
30.
you flea-bitten varmint. I'm gonna blow you out of
Well, yeah, well, let's see. I think he is, too, because 30's bigger. Let's begin. Bring out all those negative 25s and the 30s, and I'm just going to quickly get rid of the casualties.
Ba-ba-boom.
Okay, what do we have left? You know what we have left here? 5. 5 positives, okay? And we came up with you may remember, came up with a general rule for how to do this, okay? And that was
Yes!
to add integers with different signs. We subtracted the absolute values. That's why you needed to know absolute values. We subtracted the absolute values. We forgot the negatives, if you would, subtracted them, and then used the sign of the larger number. The bigger guy always wins, okay? That's why, for instance, negative 5 and 3, we went 5 minus 3. We totally forgot the negatives. Got a 2, and of course the number with the bigger number, the negative 5, that was the sign, so we used the sign of the larger.
You are correct, sir.
And that's how we really got negative 2, you see, okay? This is only with signs with integers with different signs, okay? Here's another one, negative 2 and 6. What we actually did, what you could do if you didn't feel like drawing pictures, is subtract the absolute values, the absolute value of 6, and the absolute value of 2. 6 minus 2 is 4. Now we're going to use the sign of the larger,
Bring it on.
which is 6. That's a positive, so the answer's positive 4. And as in our last big battle, we subtracted the absolute values. The absolute value of 30 is 30. The absolute value of negative 25 is 25. We got 5. Now which sign did we use? The sign of the larger number,
Bring it on.
You are
which is
correct,
positive.
sir.
Okay, and that's how we do things with different signs, okay? Remember now, as a short guy, I can tell you, the bigger guy always wins, okay?
Just remember that this thing isn't as black as it appears.
Okay, now, we did addition and we also did subtraction, but we kind of didn't do subtraction because if we got confused with subtraction, you may remember,
No.
we refused to subtract. We had an alternative.
No.
We just don't subtract. What did we do instead of subtraction if we were confused? Well, an alternative was to add the opposite. For instance, in this one, we could change it to an addition problem and the opposite of that's why you needed to know opposites. The opposite of -3 is 3. Now it usually turns it into an easier problem. 8 plus 3, okay, is going to be 11. Now, I hope you understand why you can do this, okay? You can't just go in and change a problem, okay? The reason that you can do this is you're changing it twice, okay, like a light switch. The opposite of an opposite. That's going to come into play today when we learn the new stuff, okay? Like a light switch. You start it on. If you switch it once, you've switched it. But if you switch it twice, on, off, on, you're back where you started, okay? And that's the idea. That's our strategy here, okay? So that's what we're going to do. Try and take a problem and make it an easier problem.
Do that again.
Okay, let's do another one. -5 minus +13. Now that, I couldn't do that in my head. So I add and change the sign of the second number. That was a +13, so its opposite is a -13. Well, now we're back to the rules of what? We're back to the rules of addition. Remember the rules?
Excuse me, Professor Brick.
Yes, you do remember the rules. Two numbers that have the same sign, negative and negative, they add to each other's strengths, remember? So that's something you have to remember, that you can't subtract unless you know how to add. Okay, so -5 and -13.
Yeah, baby.
Okay, -18.
Thank you, sir. May I have another?
One more, okay?
Yes.
This one is as hard as they get. You got negatives falling all over the place here, okay? That's all right. We'll try to make it into an easier problem, but it's still going to be pretty difficult. I'm going to add, change it to an addition problem, and now the opposite of the second number, the opposite of -3, is +3. Well, now, ouch, I've got an addition problem, but it's an addition problem. Let's analyze this. Let's go back to our addition rules. It's an addition problem of a mixture.
Bring it on.
We've got a battle when you have an addition problem of a mixture. Okay? Now, why was that? Well, how did I get -5? Because I took the absolute value of the two numbers. -8, the absolute value is 8. Absolute value of 3 is 3. I subtracted, okay, that's 5. Then I used the sign of the larger. So the answer is -5, okay? So you have to know your rules of addition before you can even think about subtracting, okay?
Who cares?
Well, we're going to use this a lot, you know, in word problems and in real life. For instance, when we subtract difference,
Allow me to
the
demonstrate.
word difference means subtract. So every time you see difference, okay, for instance, in this example, Bill got a +3. That's a typical score I would get. 3 over par on the last hole, and my buddy Tiger got a -2. What's the difference? Well, that's a -2 and the word difference. So we've got a negative and subtraction, okay? So we're going to take 3 and difference infers subtraction, subtract -2. Now how are you going to go 3 minus a -2? Well, I don't know. I'm going to change the sign and add its opposite. Opposite of -2 is +2. Well, now it's an easy problem.
Cool.
Okay, I'm not happy about that, but the man beat me by 5 strokes, but that's the idea.
Do that again.
One more. The average temperature in Peru is a hot 92 degrees. The average temperature at the North Pole is a freezing -52. Wonder what the difference between the two is. Now we have a negative and we have the word difference, okay? So what we're going to subtract the two numbers, one of them being a negative. 92 minus a -52. Now here's where you go, what do I do? Whenever you get confused on subtraction, you change it to an addition and change the sign of the second number. Make it an opposite. Well, now it's easy. 92 plus 52. And there's a big difference, 144 degrees. Okay, I think that's what we covered last time. So now it's time for the new stuff. You ready? Here we go. Now this, I gotta tell you, is not hard. Don't make it hard. Addition and subtraction, that was kind of hard. Okay, we covered addition and subtraction. Let's cover multiplying and dividing. Okay, and don't memorize, understand. Okay, make sure you understand the general rule. Let's take a look. I need you to know words that suggest multiplication. The product means multiply, so that means 5 times 2. But here comes a big kicker. 5 times, that was easy.
Darn tootin'.
Okay? This is the one that's going to come into play today. The word of. The word of infers multiplication. 5 of 2, 5 twos is 10, isn't it? Because 5 of 2 infers 5 times 2. Now that's critical that you understand that, the word of.
Pay attention, son. This is for your own good.
Of means times. Stick that in your head. Of means times. Okay? Big deal. What does that have to do with anything in negatives? Well, let's talk about, because negative, another term for the word negative is opposite. Obviously, the opposite of light, you're going to see this in a second, is dark, right? We can work backwards. The opposite of dark is light. This is very simple, isn't it? Don't make it hard. The opposite of negative is positive. We just switch it. The opposite of positive is negative. This is simple, isn't it? Note the use of the word of here, okay?
Excuse me, Professor Brainiac.
Okay, well, here's where it gets a little interesting. Opposite and of.
Something.
What is the opposite of an opposite? Uh-oh. Remember that times means of.
Pay attention, son. This is for
And
your
of
own
means
good.
times. Okay, make sure you stay with me here.
Well, ooh la dee da.
Or even worse, what is the opposite of an opposite? Ouch.
Welcome to Fantasy Island.
Well, I want you to consider something. Consider a light switch. This light switch with the lights on, okay? Well, not like at my house, my son always has the lights on. I mean, every light is on all the time, okay? So that's easy for me to imagine. Okay, the lights are on. Now, what if I flip that switch? Okay, I'm only going to flip it once. What's going to happen? Okay, the lights are off. I flipped it one time, the lights are off. Big deal. Okay, let's take the same light switch with the lights on as usual. My son's home. Okay, and this time let's flip it twice. And we started with it on, so off, that's one. On, that's twice, back on. Okay. What am I leading up to here? Well, wait, we're going to do a couple more here. Hold on, okay? Anybody can sit there and turn the light on and off. What if we flip the switch 4 times? Okay, think about this. 1, it's off. 2, it's on. 3, it's off. 4, it's back on. So we did it 4 times and it ended up on. I had to say that. Okay, but we had it 4 times and it ended up on. Okay, well, I got to take this to the point where you're really sick of it. Let's do it 5 times. Just bear with me here, okay? We did it 4 times and ended up on. I bet you know what's going to happen with 5 times, but just look at if you would. Okay, let's see. 1 time it's off, 2 on, 3 off, 4 on, 5 off. So we started with on and 5 gave us an off.
Wait a minute.
Okay, I'm done diving you crazy. What if we flip it
Ooh, I'm dying.
300 times? Oh, no, 300 times. Yeah, I bet you can predict, okay? What if we did it
You're despicable.
301 times? Okay, besides breaking the light switch, okay, what would happen? Well, if you think about it, an even number of switches, 0 being even, by the way, okay, that's how I remember it, 2. an even number of switches, how's that baby going to end up? It's going to end up back on, isn't it? And an odd number of switches, of course, like 301, it's going to end up off. Okay, so you really don't have to test this. That's not your homework. Okay? What does this have to do with multiplication? Well, I'm figuring most of you can get the answer, the number part of the answer in a multiplication problem. Okay? Most of us know how to multiply. It's that stupid sign that you always screw up with, especially with integers, and of course that's what integers are, the signed numbers. Okay? Well, here's my suggestion to you. Don't worry about the sign. Okay?
Now look at here.
Consider that of means times.
Pay attention, son. This
Okay?
is for your
And
own
times
good.
means of course. Okay? So we can use this principle of opposites, the opposite of an opposite of an opposite kind of a thing. Okay, to multiply, and in a second we're going to be dividing. So if you can learn this, you're hunky-dunky with the whole schmeal. Okay, we're going to use the principle of opposites. You're going to count how many opposites are in that part of the problem. And I say that part of the problem because, you know, the multiplication part. Don't count how much negatives are in the whole problem. There may be a larger problem. How many negatives are in the multiplication part or the division part of that problem? Okay, you count it. How many, and then what do you do with that number? Well, if that number, the number of negatives, is an even number, like 0, 2, 4, notice that 0 was even, okay? I don't know if it is or not, but I think of 0 as even, okay? Your answer, you'll use that will end up being positive. If you count the number of negatives in a problem, and it ends up being odd, the final answer will be negative, okay? So I just count them and then figure out whether it's odd or even, and then forget them, throw them away, erase them or something, okay?
We'll leave the light on for you.
And that's all you got to do, okay? Count the negatives.
How about a little fire, Scarecrow?
Oh, let's do it.
Bring it on.
Let's start with a real easy one. So, I mean, you say, well, geez, I already knew that. What does that have to do with anything? Well, 5 times 3, count the negatives, and I want to show you that this works for anything. Has no negatives. Okay, so it's logical. 0, 0's even. Even number, positive answer.
Excellent.
Okay, got the idea? Okay, but let's do this. It should work the same for any of them, not just the easy ones, also the difficult ones.
I haven't got a brain.
Not a problem. How many negatives are in this problem? 1. 1 negative. Now 1 is odd. An odd number of negatives, I always think of a light switch, is going to change me, right? So I'm going to have a negative answer. Of course, I know the number is 15. Is it positive 15 or negative 15?
Marvelous. Yes, indeed. Simply marvelous.
Negative 15, because an odd number of negatives.
Bring it on.
Okay, it doesn't matter which one is negative, by the way. Now this one still has 1 negative. 1 is still odd.
Excellent.
So interestingly enough, negative 5 times 3 is the same as 5 times negative 3. Just count the negatives. I don't care where they are. Okay, how about this one?
Uh-oh.
Okay, I know I get 15, but I have 2 negatives. 2 is even, so
That's the fact, Jack.
the answer ends up being 2 negatives. It's the opposite of an opposite situation. We end up with a regular, if you would. Answer ends up being positive 15. Now, you think we've covered all the possibilities.
Bring it on.
What if there's more than 2 to multiply, okay? Well, that's one long multiplication problem. I can still count the negatives. Let's see. There's 1, 2, 3 negatives. Okay, this is easy. 3 is odd. Now, wait. What's 2 times 3 times 4? 2 times 3 is 6. 6 times 4 is 24. So we started with 24, but I know I have to have
Excellent.
a negative 24. Why? Because an odd number of negatives.
Here is today's final Jeopardy answer.
Okay, how about this bad boy? I get 24, but how many negatives do I have in this case? The negative on the 2 and the negative on the 4, 3 being positive. So I have 2. 2 is even, so the answer definitely, in this case, I would bet the farm,
You're absolutely correct.
thank you, is positive 24. Count the negatives. Uh-oh, what about division? Don't make it hard. Same deal. Let's take a look. 15 divided by 3, we know it's 5, but count the negatives. No negatives. Even. 0 is even. So the answer is 5. This is easy, isn't it? I told you. Okay, let's see. A negative divided by a positive. Don't memorize. Do not memorize. I'll say a negative divided by a positive. No! count the negatives. How many negatives? 1. 1 is odd, so the answer is negative. Now wait, we got to do the 15 divided by 3. Okay, there you go. Negative 5. Okay, don't have to say, you don't have to memorize anything. You know, when I do a negative with a positive with a negative, you don't want to memorize. Just count the negatives. How many negatives? 1. 1 is odd. So we're going to, here again, a little different problem, but we're going to get the same answer. Negative 5. Okay? What about a negative divided by a negative? Okay, I don't care. I'm going to count the negatives. 2 negatives. Number is even.
You
are correct, sir. The answer is positive, because 15 divided by 3 is 5. A negative divided by a negative. Hi, Mom.
Now what am I gonna do?
Okay, now wait a minute. Here I got a multiplication and a division. This is pretty cool. I can do the the computation, but you know what? I can still count the negatives as long as it's one big multiplication and division problem. As soon as you have a plus in there, then you have to treat it as separate problems. We'll do a couple of those in a second. So I know my answer here is going to be negative because why? I have an odd number of negatives. Well, let's see. I got to work from left to right in this case. The order of operations tells me amongst multiplication and division. 12 times 3 is 36. 36 divided by 4 is 9. So negative 9. Not too bad. Okay, still same deal, except this time I have an even number of negatives. Why? 2 negatives. Okay, let's see. So an even number of negatives. My answer I know is going to be positive. And the way I do it is, okay, I know my answer is positive, so forget the negatives now. It's positive, just forget them. 12 times 3 is 36. 36 divided by 4 is 9. I told you the answer was positive. So there we go, positive 9. Okay? Told you not to make it hard. Okay? Now let's put these in, remembering the order of operations. Okay? Don't make it hard. Okay? Let's try it.
Pay attention, son. This is for your own good.
Okay, order of operations. Just for a teeny bit of a review, can we remind you that the operators are, now we know there, I'll tell you what, there's 5 operators. Plus, minus, times, division. Remember what the other one is? Plus, minus, multiplication, division. What's the other one? Exponents, okay? In other words, the operators are the things that actually operate, the things that do something, the orange things there, if you would, okay? The terms are the things that get operated upon. Terms, okay?
Wait a minute.
Now we remember that it really matters which we do first. Could we, if you would, 5 plus 7 times 10. Is it okay to add that 5 and 7 and get 12, and then take the answer 12 and multiply by 10 and get 120? Or how about multiplying by 7 times 10 first, and then taking that result and adding 5 backwards, kind of a thing? A lot of people would say, well, you can't work backwards, but you know what?
Yes, you're in deep dune.
It matters which one you do, okay? We have to follow the order of operations, and you'll have to memorize them. If you haven't already, all of algebra is based on the order of operations. And that is, do what's in any parentheses first. And if there's more than one parentheses, basically you're going to work from left to right. Then do your exponents, and if there's more than one exponents, then work left to right. Do your multiplication and division. Now don't infer that multiplication always happens before division. Amongst the multiplication and divisions, if there's more than one, I have here, remember, you're going to work from left to right. You don't get to choose. You don't get to pick whichever's the easiest. You have to work left to right. I'll give you an example of that in a second. And then after we've done that, step 4, addition and subtractions. A lot of people want to do that first because it's easier, but no, you don't get to do that until you've done your parentheses, exponents, and all your multiplication and divisions. You've done most of the problem by the time you're doing your additions and subtractions. And then I like to add another step, simplify the fraction. By that, if there is a fraction, okay? Okay, let's go back to the original problem and see what we really have to do using these order of operations. You can't just wing-wang it and do it however you feel like it, okay? So what do we do first? Do we do the addition? Or do we do the multiplication?
Nothing for you.
You do the multiplication. 7 times 10, get 70. 70 plus 5, and get your 75, okay? So you have to follow the order of operations, even though in that case, it appeared that maybe you were going backwards. It doesn't matter. Backwards, frontwards, schmuntwards. You have to follow the order of operations.
Darn tootin'.
Okay, now let's do some with negatives and integers and all that stuff. How does that work into this? Just, by reviewing our rules. Let's see.
Heart failure.
Well, let's see. We got to do what's in parentheses first. Okay, -8 and 5. Now, -8 and 5, that's a mixture. That's a battle. Who's going to win? The -8. And he's going to win by subtracting absolute values. He's going to win by 3. Okay, now he's bigger, so he's negative. Okay? Okay, now, that was parentheses. Exponents. Well, we have one exponent. That's 4 to the 2th. Okay, 4 to the 2th is 4 times 4 is 16. That was easy. Next thing, multiplications and divisions. So I don't have any divisions here, but I have a multiplication. 6 times -3. Now, it's either 18 or -18. There's one negative. Now, I'm not saying one negative in the whole problem. I'm talking about this part of the problem. There's one negative. So we have an odd number of negatives. So that's a -18. Okay? Now, we've done all our parentheses, exponents, multiplication, and division. Now our addition. -2 and -18. Now they're on the same team. Okay, so that's going to give me a -20. And the bottom, 16 minus 6, that wasn't too bad. Okay, now I've got a division problem, or simplify the fraction if you would. A -20 divided by 10. I have an odd number of negatives. So the answer is a negative answer, -2. Got the idea?
I'm such a genius.
Not so bad.
Do that again.
Okay, yeah, I think we need to do a lot of these, okay? Well, now this one, I've got multiplications and additions. Who wins? Well, of course, multiplication wins over addition, but I have 2 multiplications. Technically, it doesn't matter, but I'm going to do, the leftmost multiplication first, and that's 12 times -5. That should give me, what, a positive answer or a negative answer? I have an odd number of negatives, so that would give me a negative answer. And on the other side, the -3 times -6, I have to do that multiplication first. I have 2 negatives in that case. That's going to give me, that's an even number of negatives. That's going to give me a positive. Okay? You see, this is not that easy. Okay, when you're doing all of them mixed together. Okay, so you did all your multiplications. Now it's time to do an addition. Okay, now this is an addition of things that are on different teams. So we're going to have to have a battle here, and who's going to win? The bigger guy. Okay, you're going to subtract and use the sign of the larger, and that's the -60 is larger. So we subtracted, we got 42, and we used the sign of the larger. The answer is -42. Okay. Well, we use the same rules when we do for numbers that we do for letters. Because remember, variables or the letters really are numbers. Okay? Now what if I asked you to take this expression and fill in every place you see an A, I want a -2. I want a -2. Every A, and every B, I want a 4. Okay? As you can see, where the A was, there's a -2. Okay? And where the B is, there's a 4. Now we have to do what's inside parentheses first, and I did 2 times -2. Okay, I didn't do the exponents yet. I have to do what's inside parentheses. 2 times -2, that's an odd number of negatives because there's one of them. So I got a negative answer of -4. Okay, now I do my, if you would, exponents. -4 to the 2th. Now here's where I'm going to confuse you. -4 to the 2th. How many negatives are in -4 to the 2th? Remember what -4 to the 2th means. -4 times -4. I said it. Now you only see one, but really it infers that there's 2. So that -4 to the 2th is going to end up giving you a positive 16. And the other one, 4 to the tooth, is going to give you a positive 16 as well, okay, because you counted the negatives. Okay, now I got to do some multiplication. The 3 times 16, okay, and I get 48. Now, if you have trouble with this subtraction, you could say that it's not 16 minus 48, but change it to an addition, 16 plus, and change the sign, 16 plus negative 48. Okay, that's what I like to do. Now, I got an addition problem, and I've got two numbers that are on opposite sides, so as weird as it may seem, I started with a subtraction, changed it to an addition, at least it's an easier addition, and now what I'm going to go back to is a subtraction, because to add numbers that are on different sides, I subtract. 48 minus 16, and use the sign of the larger, which is the 48, which is negative, and that's the answer.
Excellent.
Okay, negative 32, that's tough, huh? Consider, the reason we're doing these letters is that variables are called variables. Variables can vary. Okay, let's try it.
Oh, right, guys.
We can get different answers depending on what we put in for each letter. How about this one? What if every place I have an X, I'm going to put in a 7, and every place I have a Y, every place I'm going to put in a minus 3. Okay, you see what I did there? Every place I have an X, there's a 7, and the both places I had a Y, both places a negative 3. Okay, now I've got to follow my order of operations, and that is parentheses, but I don't have anything to do inside it. I have parentheses, but I don't have anything to do inside of them. So I'm going to skip that step. I'm not really skipping it, I'm doing it. Okay, there's just nothing to do. Okay, now exponents. Now that 2, who does he have power over? He only has power over the negative 3, that little tooth. And how many negatives are there in this exponent? Negative 3 times negative 3, that's 2 negatives, okay? So I'm going to end up with a positive answer, aren't I? Because an even number of negatives, okay? Now, I've got multiplication. 2 times 9, 18. Or you could have thought of it, you say, is that a negative 2 or a subtraction? Well, if you think of it as a negative, negative 2 times 9 is negative 18. If you think of it as a subtraction, you're going to subtract 2 times 9 and get minus 18. So you can think of it as a negative or a subtraction. You get the same answer, just not both. Okay? Okay, let's see. Now I've done my parentheses, exponents, multiplication and division. Now it's addition and subtraction, but I have to work amongst these left to right. So I have to do the 49 minus 18 first. Doesn't matter which is easier, you have to work left to right in that case. And now I've got a battle, 31 and negative 3, the big guy is going to win. I'll subtract and use the sign of the larger, and the sign of the larger is positive, so there's your answer.
Yeah, baby, yeah!
Okay, now let's take the same expression, the same letters, and since those letters are variables, they can vary, okay, and put in different numbers, okay, and of course we'll get a different answer. It's good practice, okay?
Thank you, sir. May I have another?
Here we go, baby. This time, it's the same expression. I'm going to put in, instead of the x's, I'm going to put in a negative 5, there's only one x, and instead of the y, I'm going to put in a negative 2. Every place I see it. Okay, let's see. Every place I see an x, it told me to put in a negative 5, and every place I see a y, told me to put a negative 2, and I put it in both places. Okay, now I'm going to go through my order of operations. Are you getting sick of it? Good, you're going to know it. Number 1, do what's in parentheses first. Well, while we do have parentheses, there's nothing to do inside of them, okay? So we can move on to the next step. That was parentheses. Now exponents. Now the exponents is the most common error in this type of a problem, especially with negatives. Because negative 5 to the tooth, on close inspection, you'd think, well, there's only one negative. But what does negative 5 to the tooth really mean? Negative 5 times negative 5. So really, in reality, how many negatives are there? Well, there's 2 negatives, and an even number of negatives, 2, results in a positive answer. Okay? Now that other exponent, the negative 2 to the tooth, the green one there, there again, I'm going to have 2 negatives, and that's where the positive 4 comes from. Even though you only see one, You have to, the 2 infers to the 2th power infers 2. Now, if it was to the 3, it would be, how many? It would be 3 negatives, okay? You'd end up with a negative answer. Okay, get the idea? So be afraid of exponents. Okay, now we got to do multiplication. The 2 times the 4, that's not too bad. And now we've done everything up to our addition and subtraction. We have to work left to right amongst the addition and subtractions. You don't get to do what you think is easiest. Okay, so we have to do 25 minus 8. Okay, and now we've got an addition problem. Now you integer addition experts know that we've got a battle here. 17 and negative 2. The bigger guy is going to win the battle because they're different signs, but you're going to have casualties. So we're going to subtract and use the sign of the larger. And the answer in this case, totally different answer because it was different numbers, is 15.
I make this look good.
Yeah, it's not so bad if you know the rules. Okay?
Uh-oh.
Okay, now let's go back to this exponent thing and make sure that I really think people screw this up. Okay? Consider that if I, for instance, put in a negative 2 for A, and you say, well, that's already a negative. I know it is, okay? But if I put in a negative 2 instead of A, okay, not instead of negative A, instead of A, what's going to happen? See how it could be confusing? Well, in that case, that 2 only has power over the A. You know why? Because that negative is kind of like a negative 1 times A. So you're supposed to do exponents before you do multiplication, aren't you? Okay? So the 2 in this case, in this problem, we're about to do another one very much like it, but in this problem, the 2 only has power over the A. So we're going to do that negative later, that black one. And we'll do our negative 2 instead of our A. We're supposed to put it in and square it. Okay, now what is negative 2 to the 2th power? It's a positive 4. Now, bring down your negative, and you know what? That's the answer.
Well, ooh-la.
Ooh-la-dee-da. Well, wait a minute. Let's do the same thing with parentheses. Okay? Take a look at this. This looks like the same problem, except I threw parentheses. Why does that change it? Well, parentheses are the king. You have to do what's in parentheses first. Once again, we're going to put in negative 2. But now, that little 2 to the 2th power, if you would, that black 2, has power over the whole poopsie. Why? Because we do what's in parentheses first. Okay? Whole different deal. Let's take a look. Of course, there's that black negative, and then there's the negative of the negative 2, the red one. Okay? Now, what is negative of negative 2? Think of the opposite of an opposite. That's positive. We had to do what's in parentheses first in this case. Subtle difference, but huge result in the answer. Okay? So now what's inside parentheses is just a positive 2, and of course a positive 2 to the 2th power is a positive 4. Okay? Remember the last answer was negative 4. Okay? Okay, that's enough for today. Let's take a look at what we covered today. Our new stuff was multiplication of integers. Now, what was the problem? I knew how to multiply. It was a stupid sign, remember?
Now I say look at here.
We considered that of means times,
Pay attention, son. This is
and
for your
times
own good.
means of. Okay, very important little word, that of, isn't it? So what we did was we used the principle of opposites to multiply and to divide. Okay? We counted how many negatives were in each problem, each multiplication and division problem. We counted it and decided whether it was odd or even. If it was even, our final answer ends up being positive. If it was odd, our answer is negative.
We'll leave the light on for you.
For instance,
Fantasy Island.
and why was that? I want you to be able to imagine this. If the lights are on and you flipped it once, it was off. If it was on and you flipped it twice, went off, but it came back on again. Remember the opposite of an opposite. If we flipped it 4 times, you start getting sick of it. Off, on, off, on. What did it end up? On 4 times. it ended up being on when it was an even number. So we remembered 5 times. Okay, now it ended up being off.
Wait a minute.
So when we flipped it,
You're despicable.
when we flipped it, an even number of switches, you can imagine that light switch, I hope, in the future. I hope you won't forget it. The answer will be on.
Oh.
And an odd number of switches, the light ended up off. So let's do some.
How about a little fire, Scarecrow?
Remember, when there was no negatives, 0 is even.
Excellent.
We got a positive answer, of course, because it's even.
I haven't got a brain.
When there was 1 negative, it didn't really matter where it was. Okay, with the 5,
Marvelous. Yes, indeed. Simply.
or with the 3, it really didn't matter if you had 1 negative.
Excellent.
Since 1 is odd, the answer ended up being negative. Now, if you had 2 negatives, since 2 is even, the answer ended up being positive.
That's the fact.
Now, if we had more than 2, that's all right. This still works. I wouldn't tell you something that doesn't always work. You still count the negatives. Okay, now in this case, there's 3 negatives. It's odd, so we're going to end up with a negative answer.
Excellent.
Okay, same deal, same numbers.
Here is today's final Jeopardy answer.
We have 2 negatives. 2 is even, so of course you're going to get the same answer, same absolute value if you would 24. But in this one, since you have 2 negatives and 2 is even,
You're absolutely.
correct. Positive 24. Okay, now that's the multiplication. The same deal works with division. If there's no negatives, of course, none, or 0 is even, we get a positive answer. If there's 1 negative, one being odd, it really doesn't matter where that negative is, okay, with the first number or the second number. If there's only 1, that's all I got to do is count it. The answer's still going to be negative, okay? So all you have to do is count. Doesn't matter where. Here again, it's division. Got an even number of negatives, 2 of them,
You are correct, sir.
and the answer is positive in this case. Not too bad.
Now what am I gonna do?
Now this one was a mixture, okay? Order of operations told me to work left to right, but it's one big problem, if you would, so I could count the negatives, okay? Or I could do separate problems if you so chose, okay? You could do the first 2, get a positive, multiply a positive times a negative if you think about it. I'm sorry, a negative times a negative, get a positive, then a positive divided by a negative, and there'd be 1. You'd still get a negative answer, but the easiest thing to do is count them up, and I have 3 negatives. 3 is odd. The answer is going to be odd. The answer is going to be negative, okay? Now this one, same deal, but it had 2 negatives, and 2 is even. So the answer, similar, but the answer is positive.
Oh, you darling, you've done it again.
Of course.
Never underestimate the power of...
Okay, remember that all of algebra is based on what you're going to have to memorize, the order of operations, okay? The whole semester we're going to be covering this. So please memorize them. You're going to do what's in parentheses first. Then, and only then, you're going to do exponents. And if you have more than 1 exponent, you're going to work left to right. Then you're going to look for all your multiplications and divisions. And if you have more than 1 of them, or any mixture thereof, you're not going to do multiplications first because they're easier. You're going to work amongst them left to right. Then after all that's done, you're going to look for your additions and subtractions, which likely is all that's left. And there again, you're not going to do the easiest ones. Amongst the additions and subtractions, you're going to work left to right. And then if you have a fraction, you'll simplify it. Okay?
The great Oz has spoken.
Let's try the order of operations. Let's see. Parentheses, don't have any. Exponents, don't have any. Multiplications. Actually, I have two multiplication problems, two separate problems. One of them, 12 times negative 5, has 1, which is an odd number, 1 negative. That's going to be a negative 60. The other, negative 3 times negative 6, has 2 negatives. That's 2 being an even number. That's going to be a positive answer. Okay, so I had to do all my multiplications first. Now I do my additions. You remember from the last show, to add numbers, if they have the same sign, you just add them together. If they have a different sign, you have a battle. Like in this case, we have different signs. So we'll have a battle and use the sign of the larger. And in this case, your answer will be negative 42. Okay? Remember the idea of doing order of operations with letters. Okay? Because letters are just placeholders for numbers. And those numbers can be negative just like anything else, okay? So in this example, you may remember, every place we had an A, we put in a negative 2. And every place we had a B, we put in a 4. Okay? Now, we did what is in parentheses first, 2 times negative 2. That's all we did in that step, 2 times negative 2. Okay, because you have to do what's in parentheses first. 2 times negative 2, there's only one negative, so the answer ends up being, 1 being odd, answer ends up being negative. Now we do our exponents, negative 4 to the 2th. How many negatives do we have there? 2. Okay, so we have an even number. So the answer ends up being positive. Let's do the multiplication, 3 times 16. And now I do my subtraction. I'm going to change my subtraction to an addition. I got a battle. The bigger guy is going to win.
Excellent.
Code Red, repeat. We are at Code Red.
Holy, go to war. You distance learning students, I'm going to stop right here and remind you, you know what time it is? Take a look. It's time.
Ooh, I'm dying!
Yep, you have to take your first test. Now that means that you're going to mail me your homework, okay? Mail me your homework summary, and you're going to go to, and before you go to take that test, make sure you do the review test that I gave you, okay? You're going to be very sorry if you don't do that, okay? Do the review test, then go to the assessment center, take the test, kick chicken. I know you will do that, okay? So I guess it's just time right now to do your homework, okay? So do your homework, don't forget about the test, okay? If you have any, remember how we do our homework, we don't study it. We do it, okay? And if you have any problems, you know what to do? You can always go to the home page, which is www.montgomerycollege.edu/pre-algebra. And if you're not happy with that, remember you can email your old buddy, me, bwitte@mc.cc.md.us. Okay? And until next time, I appreciate you listening. Thank you. Thank you very much.